This is Chapter 10.5, Exercise 1 through 10. Section 10.5 has to do with binomial expansion. And specifically in Exercise 1 through 10, use Pascal's triangle to expand each binomial. And I'm going to work out the odd number problems 1, 3, 5, 7, and 9 in this set. And because there are going to be different exercises to be worked, I'm going to, right from the outset, work out a version of Pascal's triangle that we're going to be able to come back and access to solve the remainder of our problems in this set. So the first row, if we have, say, a binomial a plus b, only a plus b to the 0 power, that's just going to be 1. And then if we have, I'll make it over here, leave a little more room, 1. If we have quantity a plus b to the first power, well, we're going to have 1 and 1. So we have, that first one's going to be row 0. Okay, the next one's going to be row 1. And the number of row is the same as the power of the binomial being expanded. Next we have row 2, and that's going to represent this quantity a plus b squared. So we come down on the edge, we have 1, and then 1 plus 1 here is going to be 2. So we have 1, 2, 1. And then row 3 is going to be 1, and then 1 plus 2 is 3, 2 plus 1 is 3, and then 1 on the edge. Row 4 is going to be 1 on the edge, then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and on the edge 1. And so now we have the wherewithal to figure this out for the Pascal's triangle, and I'm going to just continue here, right here on the left. I hope I have enough room here. Anyway, what we're going to have, our first term is going to be, we have 1, and 1 times, we have 2 to the 0 power times x to the 4th power. And our next term is going to be plus 4, again from Pascal's triangle. We're going to have 2, well, we're going to have 2 to the 1st power, and then we're going to have x to the 3rd power, plus our next coefficient is 6. We have 6. We have 2 squared times x squared, and then we have plus, I'm making another row here, we have 4, 2 to the 3rd power, and x to the 1st power, plus we have 1, we have 2 to the 4th power, x to the 0 power. And just writing all this out and simplifying, what we have is x to the 4th, and we have x squared times 2, because 2 to the 1st power is 2, so we have plus 4 times 2, which is 8 x cubed, plus we have the next one is we have 6 times 2 squared. Well, 2 squared is 4. 4 times 6 is 24. So we have 24 x squared. Our next term we have here is 4 times 2 to the third power. Well, 2 to the third power is 8. 8 times 4 is 32. So we have plus 32x. And then our final term is just going to be 2 to the fourth power, which is 16. So this is going to be our binomial expansion for problem number 1. Now we've done problem number 1, but I'm going to continue expanding the triangle that we're going to come back and access here. I think we're going to go through row 8. So row 5 is going to be 1, 1 plus 4 is 5, 4 plus 6 is 10, 4 plus 6 is 10, 4 plus 1 is 5, and then 1. Row 6, we're going to come back and use these. We have 1, 1 plus 5 is 6, 5 plus 10 is 15. In the middle, 10 plus 10 is 20, and then 10 plus 5 is 15. 5 plus 1 is 6, and then 1 on the edge. Row 7, we have 1 on the edge. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. And 6 plus 1 is 7. And then finally 1 on the edge. And row 8, I think this is the last one we're going to do here. We have the edge is 1. Then 1 plus 7 is 8. 7 plus 21 is 28. And then 21 plus 35, I believe that's 56. And 35 plus 35 is 70. 35 plus 21 is 56. And then 21 plus 7 is 28. 7 plus 1 is 8. And 1. So we're going to come back and use this triangle for the subsequent problems here. Okay, that's 2 is n plus m to the 6, but we're going to do our odd number problem. So we have this 4a, this quantity 4a minus b cubed. And so what that's going to be is cubed. We're going to have some coefficient that we're going to get from the Pascal's triangle times 4a, and we're going to have 4a to the third power times this negative b to the power of 0 plus the coefficient we're getting from Pascal's triangle. We're going to have 4a, 24a squared, and then we're going to have negative b to the first power, and that's going to be it, plus some coefficient. We're going to have 4a to the first power, and we're going to have this negative b squared, and finally I think our last term is going to be some coefficient times 4a to the power of 0, and we're going to have negative b to the third power. And so being in 3, it's going to be row 3. So we go back to access our Pascal's triangle that we created. So we have a 1, 3, 3, 1 pattern. So from row 3, 1, 3, 3, 1. So I'm going to fill in red here, 1, 3, 3, 1. And so that being in place, we're just going to write things out. So what we have is 1 times, well, what's going to be 4 to the third power? That's going to be 4 times 4 times 4, which is 64. So our first term is going to be 64, a to the third power, and then negative b to the power of 0 is just 1, so we're just going to leave that in place. Then we're going to have plus. Now I'm going to hedge a little bit, because I'm going to wait to put the plus until we see what kind of sign we have. So we have 4 squared, which is 16, times 3. 3 times 16 is 48. So we have 48 a squared, and we have negative b to the first power. Well, the negative, since it's to the first power, is going to be multiplied times this 48. So that's going to make this minus 48b. Next, we're going to take this, again, I'm not going to put the sign in there yet till we have it figured out. We have 4 to the first power times 3, which is going to be 12. And it's going to be 12a. And then we have this negative to the squared, which is going to take away the negative sign. So we're going to have b squared, and we're going to have plus. And then our final term is we're going to have 4a to the 0 power, which is 1 times 1, but negative b to the third power, so we're going to get minus b to the third power, or b cubed. So this is going to be our answer using Pascal's triangle for problem number 3. Next, problem 5. We have 3x plus 2y to the 7th power. So this is going to be a substantial expansion, right? So we're going to have, I'm just going to write out places. We have some coefficient times this quantity 3x to the 7th power times this 2y to the 0 power, and we're going to have plus some coefficient 3x to the 6th power, and then we're going to have 2y to the first power plus some coefficient, we'll have 3x to the 5th power, and we're going to have this 2y squared plus some coefficient, we'll have 3x to the 4th power times 2y to the 3rd power plus some coefficient 3x to the 3rd power and this 2y to the 4th power, and then we're going to have plus this some coefficient 3x squared and this 2y to the 5th power plus, I'm going to come down here now, some coefficient, we have 3x to the 1st power and this 2y to the 6th power, and then this last one we're going to have some coefficient, we're going to have 3x to the power of 0, and then we're going to have this 2y to the power of 7. So we should have 8 terms total. 1, 2, 3, 4, 5, 6, 7, 8. And if we go to the triangle to see what coefficients we need to place, and here's our triangle again, our row 7, we have 1, 7, 21, 35. So we go to put in 1, 1, 7, 21, 35, and then we have symmetry, so this one's going to be 35 here, and 21, and then 7, and then 1. Okay, now we're just going to try to simplify as much as we can. We're going to have 1 times 3 to the 7th power. Okay, that's going to be x. Our next term, and these are all going to be plus, so that's not going to be a question. We're going to have 7 times 3 to the 6th power, x to the 6th, then y. We got 2y to the 1st power, So that's going to be times 2 times y, plus we're going to have 21, we're going to have 3 to the 5th power, x to the 5th, 2 squared, and y squared. Next, we have 35. We're going to have 3 to the 4th power. We're going to have x to the 4th power. We're going to have times 2 to the 3rd power times y to the 3rd power. Then we're going to have plus 35. We're going to have 3 to the 3rd power, x to the 3rd power, and we're going to have times 2 to the 4th power. See, that's legible. And then y to the 4th power, and I'm going to make this next row down below, plus we have 21, 3 squared, x squared, and we have this 2 to the 5th power, y to the 5th, and then we have plus 7 times 3 to the 1st power, which I'm just going to put in as 3, x, and we're having 2 to the 6th power, y to the 6th, and then finally we're going to have 1, our last term 1, times we have this 3x to the 0 power is just going to be 1, so we're just going to ignore that. We're going to have 1 times 2 to the 7th power, y to the 7th power. And so from here, it's just going to be a matter of just simplifying and putting all these numbers in their place, each of their places. We're going to have 3 to the 7th power. I can't readily recall what it is, so 3 to the power of 7. I don't have somehow my calculator's not being active. Okay, let's hit it right there. Let's try it again. 3 to the power of 7. We get 2187. So we're going to get 2187x. Plus, we're going to have 7 times 3 to the 6th power times 2. Okay, 7 times 3 to the 6th power times 2. So we get, okay, 7 times 3 to the power of 6. We had that times 2 in the wrong place, times 2. So we get this, 10,206. Okay, so we go here, 10,206. We have x to the 6th, y, plus, next one we're going to have is this one, 21 times 3 to the 5th times 2 squared, which is 4. So 21 times 3 to the 5th times 2 times 4. 21 times 3 to the power of 5 times 4. And we get 20,412. So 20,412 412 x to the fifth y squared. Next, we go to this one, 35 times 3 to the fourth times 2 cubed, which is 8. So 35 times 3 to the fourth times 8. So 35 times 3 to the fourth times 8. I think 3 to the fourth is 81. So 22,680. So we get 22,680 x to the fourth y cubed. And the next one we're going to be looking at is this one, 35 times 3 cubed. Well, it's going to be 3 cubed is 27. So 35 times 27 and 2 to the fourth is 16. So 35 times 27 times 16. 35 times 27 times 16. And for that we get 15,120. So the numbers start to go down a little bit. So 15,120 and that's going to be x to the third, y to the fourth. I'm going to make another row down here. Okay, so we have 5 terms. Okay, next one is you have 21 times 9 times 32. 2 to the fifth is 32. So 21 times 9 times 32. So 21 times 9 times 32, we get 6,048. So we get 6,048. We get x squared, y to the fifth. Okay, next we have 7 times 3 to the first power. That's going to be 7 times 3, and 2 to the sixth power is 64. So 7 times 3 times 64. Okay, 7 times 3 times 64, we get a 1,344. So plus 1,344 x y to the sixth. And finally we have the last term, 2 to the seventh. Well, 2 to the 7, I hope it's 128. 2 to the power of 7 is 128. So yeah, that's it. So we have plus 128 y to the 7th. So that's it. Yeah, this is kind of a long one and has a level of complexity with everything drawn out here. Next, let's go on to problem 7. I hope it's not going to be as extensive, and it isn't, because it's only 4 terms. So what we're going to have is some coefficient, and we know that's going to be 1, and we're going to have 3c, let's put an equal sign here, 3c to the fourth power times negative d to the 0 power. Okay, then we're going to have plus some coefficient. We're going to have this 3c to the third power, and we're going to have this negative d to the first power plus some coefficient 3c squared, and we'll have negative d squared. That's our third term. We're going to need to have 2 more, plus some coefficient. We have 3c to the first power, and we'll have this negative d to the third power. Oh, excuse me. Yeah. And then the last one we're going to have plus some coefficient, and we'll have 3c to the power of 0, and we'll have this negative d to the power of 4. So that's going to work out, and then we're looking at row 4. So we go to our Pascal's triangle, and we see row 4, we have 1, 4, 6, 4, 1. So we go back here, 7, and we go to 1, 4, 6, 4, 1. I think we'll be able to do this a lot easier than we did number 5. So what we have is this 3 to the 4th power, that's going to be 81. And so we have 81c to the 4th power, and this negative d to the 0th power is 1. And the next one we're going to have is minus, and I know because negative d to the 1st power, well, the negative sign in the 1st power, that's going to be negative. And we're going to have 4 times 3 cubed. That's going to be 4 times 27, which is 108. Okay, we have 108 c to the 3rd power, and then we're going to have plus, and I know it's plus because this negative d squared will be d squared, and I did forget something, didn't I? We're going to also have on this second term d, c cubed d, then plus, we're going to have 6 times 3 squared. Well, 3 squared is 9. 9 times 6 is 54. So we're going to get 54 c squared and d squared. And then we're going to have minus, because I know this negative d cubed, that negative sign is going to be minus. So 4 times 3 is 12. So we have 12c, and we have d cubed. And our last term is going to be simply this negative d to the 4th power, because this 3, we have 1 times 3 to the 0th power, well, that's going to be 1. And this negative sign is going to square out, so we're going to have plus d to the 4th power. So this is going to be our answer to problem number 7. And our last one in this set that we're going to work is this a minus b to the 3rd power. And so being at the 3rd power, that means we're going to have 4 terms. The first one, we're going to have a coefficient times this a to the 4th power, and I'm going to have this negative b to the power of 0, and then we're going to have plus, blank for coefficient, this a to the 3rd power, and this negative b to the 1st power, then plus coefficient, we have a squared, and this negative b is also squared. So I want to square on the outside. Negative b squared, plus we have some coefficient a to the 1st power, and this negative b is to the 3rd power, and that's going to be that what that's going to do is make it minus when we work that out. So that's going to work out. Then we have plus some coefficient, which I think is 1. We're going to have a to the 0 power, and we're going to have this negative b to the 4th power. So we can just work all this out, but first we're going to go and get a 3. We should have 1, 2, 3, 4. Let's see. Well, I have this kind of mixed up in order, don't I? This should be 3 here. It helps to go over these things. And the next one we have is going to be 2, 1. And then we're going to have a to the 1. And this last one we have 0, 3. So I think I fixed it up. Okay, that'll match this time. We have 4 terms. I think I can do this without a calculator, except we're going to go get the 4. And to do that, we go to row 4. And in row 4, we see 1, 4, 6, 4, 1. Actually, it's going to be row 3, right? Row 3, 1, 3, 3, 1. Gosh, distracted. 1, 3, 3, 1. Okay, so we have 1 times a to the third, so we have a to the third power. And the next one, we're going to have this 3a squared, but we have minus this negative b to the first power. So we're going to have minus the 3 we'll have a squared b, and our third term is going to be 3, this time 3 ab squared, and our last term, we're going to have this negative b cubed, so that's going to be a minus, and this 1, a to the 0 power is 1, so minus 1 b cubed. So that's going to be our answer. It's number 9. I invite you to also look at number 10. We have to the 4th power. That should be pretty easy. Anyway, these are all the odd numbered exercises worked out. Good luck on your even number problems. I hope this is helpful to you. And thanks for viewing.